Welcome back, everyone. So we're going to talk about just sequences in this video, and then the next video I'll do the intro to logarithms, but for now we're just going to do sequences. So starting off, we're going to look at different sequences that we have here at the top for your warm-up. So we're just looking at a string of numbers, and we're looking to see what the pattern is, and we're going to look to see what would be the next three terms. So if I have a sequence going from 1 to 4 to 7 to 10 to 13, well, the consistent change between all terms here would just be plus 3. So because I'm doing a change of plus 3, my next terms would be 16, then 19, and then 22. So if I look at the next set, my next sequence here, so to go from 4 to 8 to 16 to 32 to 64, so my clear consistent change throughout each of these terms would be times 2. So it has to be the same change throughout the entire sequence. So that means my next term would be 128, and then we're looking at 256, and then we're going to look at 512. And then over here, looking at this last sequence up here, so to go from 7 to 2 to -3 to -8, well, your change here, we're going to subtract 5, which means my next term here would be -13, and then we have -18, and then -23. So looking at these different types of sequences, we have actually specific types of sequences. So the first one we're going to look at is going to be an arithmetic sequence. So with arithmetic sequences, we're looking at a constant change. So when I say a constant change, that's similar to number 1 and number 3. So these we're changing by a constant value of addition or subtraction. So that is going to be the type of change that we're going to have in what we call arithmetic sequences. So with arithmetic sequences, we have two different forms, or two different types rather. So we have what we call the explicit form, and then we have the recursive form. So the recursive form specifically only lets you find the consecutive term, which is a fancy way of saying only the next term. Whereas the explicit form lets you find any form, or any term rather. So a lot of people ask me is like, well, why do I need to know the recursive form if the explicit form lets me find anything? Well, the recursive form, we really just need to know the form and we need to know the notation of it because it's still useful in some formulas. But I will say majority of the time we are going to use the explicit form. So I'll let you guys kind of take a second and look over the actual formulas and look at what each value represents. I will say the notation and how you write this is going to be very important. So what I mean by that is over here we have a sub n. So make sure you're not writing it as a of n. It has to be a subscript. So you need to write that in kind of like an exponent, but in the lower right rather than the upper right. So just a little notation for you. So we're going to go ahead and look at geometric. So it's the same idea. However, we're looking at what we call a constant proportional change. So that's going to roughly translate to a multiplicative change, which means we're looking at an exponential change. So with geometric sequences, this is where we're going to we're going to multiply or divide. So once again, we also have recursive and explicit form. However, with your explicit form, this is going to take form of your exponential equation. So it looks similar to y equals a times b raised to the x, but it's going to be written a little bit different. So same idea as before, make sure you're paying particular attention to the notation, and we'll just kind of go right into it. So down here, so we're not going to outright tell you what type of sequence it is. You have to determine the type of sequence based on the string of numbers that we give you. So if I have 5, 11, 17 to 23, my change here is going to be plus 6. So because I'm strictly adding, that tells me it's going to be arithmetic. So I'm going to have an arithmetic sequence. And what that tells me is because it's an arithmetic sequence, that means we're going to have a common difference. And a common difference is denoted with the letter D. And then your change is going to be what we're changing by. So this is going to be interchangeable. So now for your recursive form, so we're going to have a sub n is equal to a sub n minus 1. And then you're going to add or subtract whatever your common difference is. So in this case, it would be plus 6. And then for your explicit form, so we have a sub n equals a sub 1 plus n minus 1 times your common difference. So what you're going to plug in is going to be the value of the first term and your common difference. So the value of the first term of your sequence, which is going to be 5. And then we're going to plug in the common difference, which is 6. So this would be your explicit form. And then we're going to use this explicit form to actually find the value of the indicated term down here at the bottom. So that down here, this tells me I want to find a sub 12. So this tells me my n value is going to be equal to 12. So when I plug in, so 5 plus 12 minus 1 times 6. So this is going to be 5 plus 11 times 6, which is going to be 66. So 66 plus 5, which is going to give you 71. Now, another note to add in is, even though you have your explicit form over here for an arithmetic sequence, remember that an arithmetic sequence is a constant change, which means it would be linear. So what could happen is you may be expected to change your explicit form into slope-intercept form. So what I mean by this, so I'm going to rewrite my sequence. So a sub n equals 5 plus n minus 1 times 6. And I'm going to go ahead and just convert this to slope-intercept form. So I'm going to rewrite it as y equals 5 plus n minus 1 times 6. So we're going to rewrite it as a y equals, but we're still going to keep the n value to kind of give us the indicator that we're talking about a sequence. So now you're going to distribute your 6. So when you distribute, so 5 plus 6n minus 6, so this would be 6n minus 1. So, I mean, I've seen some write it as y equals. I've still seen some people write it as a sub n equals 6n minus 1. The actual letters, I guess, don't necessarily matter, but the form is what we really want to focus on. So we could write it as explicit form, which is what we have up here, or we could do it in slope-intercept form using whichever kind of set of values or letters we want to use. So looking at the next one, so at number 5 here, so we've got 3 to 12 to 48 to 192 to 768. So my constant change here is going to be times 4. Now, because we're multiplying in this case, this is going to be a geometric sequence. So a geometric sequence is going to have what we call a common ratio, which is going to be denoted with the lowercase letter r. And then that common ratio is going to be your change, which that's what we're going to write right here. So my recursive form, so we're going to have a sub n equals a sub n minus 1, and then you're going to multiply by whatever the factor is that we're multiplying by, which is your common ratio. And then your explicit form is going to be a sub n equals a sub 1 times your common ratio raised to the n minus 1. So what you're going to write in is going to be the value of the first term and your common ratio. So the value of the first term, which in this case is 3, and then my common ratio, which is 4. So there's a few different ways that you could write this. So I could also write it, let's be consistent with our sequence first. So 3 parentheses 4 raised to the n minus 1. So this is another way that you could technically write it. So I'll kind of slide that up there. And then we'll do the next conversion actually in a bit. So let's go ahead and find the value of the 10th term first. So this tells me that my n value is going to equal 10. So I'm going to do 3 times 4 raised to the 10 minus 1, which in this case would be 3 times 4 raised to the 9th. And values, when they get this big, we would let you use a calculator. However, if their values are small enough, we could put these on non-calculator sections of assessments. So just know that we could put these types of questions anywhere. So when I plug that in on my calculator, we're going to get 786,000 432. So that would be your 10th term. So now I'm going to go ahead and convert my explicit form of this sequence. I'm going to convert it to exponential form. So just like how we can convert arithmetic explicit form to slope-intercept form, I'm going to convert my explicit geometric sequence form into an exponential form. So y equals a times b raised to the x. So I'm going to take 3 times 4 raised to the n minus 1. And then what I'm going to do is I'm going to kind of separate this value here. So this is going to give us 3 times 4 raised to the n times 4 raised to a negative 1. So I'm going to separate the exponents into two separate terms. And then when I do this, I'm going to rewrite 4 to a negative 1. So those negative exponents tells me I need to flip it. So 3 times 4 raised to the n, and then 4 raised to the negative 1 is going to turn into 1/4. And then I'm going to multiply 3 and 1/4 together, and that's going to give me 3/4 times 4 raised to the n. So this would be my exponential form. Because one thing you need to notice is when you're in explicit form, we get the value of the first term. But when I'm in exponential form, we get the value of the initial term. So recognizing what value you're given is going to be crucial. So looking at number 6, I would say pause here and actually try the rest of these. So the 4. So moving on. So I'm going to try to go through these a little bit quicker. So we're looking at 45 to 37 to 29 to 21 to 13. So my change here is going to be minus 8. So because I'm subtracting, this is going to be arithmetic, which means we're going to have a common difference. And because we have a common difference, that means we're going to have a d value, which is equal to negative 8. So my recursive form would be a sub n equals a sub n minus 1. And then you can add a negative 8, but really when you add a negative, that's just the same as subtracting. So you can just say minus 8. And then your explicit form here, so a sub n is going to be equal to your first term, which in this case is 45, and then plus n minus 1. And then because your common difference is negative, you can't just write a negative 8 at the very end, because this looks like I'm just subtracting 8. So what you've got to be careful about is when it's negative, you have to put it in parentheses. So if I want to plug this in on, or actually let's try to do this by hand. So we want to find the 15th term rather. So we want 45 plus 15 minus 1 times negative 8. So 45 plus 14 times negative 8. So 14 times negative 8, let's see, that's 112, negative 112. So 45 minus 112. And then when I subtract, that should give us negative 67. Ta-da. So now let's go ahead and convert this to slope-intercept form real quick. So we're going to have 45 plus n minus 1 times negative 8. I'm going to distribute that negative 8. So this is going to go to my n and my negative 1. So 45 minus 8n and then plus 8, which means my equation here, we're looking at negative 8n plus 53. So I know we don't have the directions that tell you that you have to convert it to the specific form, like slope-intercept form or exponential form, but I'm going to go ahead and just do it just to get in the habit, and that's actually going to help you that's actually going to help you a lot more when we get further on into exponential equations and logarithmic equations. All right, so down on number 7 here. So we're going from 10 to 11 to 13 to 16 to 20 to 25. So if I look at my change here, so I'm doing plus 1, plus 2, plus 3, plus 4, plus 5. Now, while we have a change that is consistent-ish, it's not a constant change and it's not a constant proportional change. So even though we see a pattern, it's not going to be one of the sequences that we see. So what I mean by that is you would say this is not a sequence because it's not arithmetic and it's not geometric. It is a type of sequence, just not one that we're going to look at. So whenever that happens, you can just put X's, or you can even write NA. As long as I see not a sequence somewhere, and then you can fill it with either X's or NAs or whatever, not applicable, then we're good. So looking at the next one. So now we're looking at 243 to 81 to 27 to 9 to 3. So this is getting pretty small pretty quick. So when I see a drastic change like that, that usually tells me it's going to be geometric. So if your change isn't as obvious as you want it to be, you can look for your common ratio by simplifying the ratio of your second term over your first term. So this would be 81 over 243, which when you divide and when you simplify, you're actually going to get 1/3. So this is going to be geometric. Which means we're going to have a common ratio with an R value equal to 1/3. So my recursive form, we're going to have a sub n, which is equal to a sub n minus 1 times 1/3. And then your explicit form here is going to be a sub n equals a sub 1, which in this case is 243. And then times your common ratio, which is 1/3, raised to the n minus 1. So when I plug in, I want to find the 8th term. So this is going to be 243, parentheses 1/3. That's a 3. I can never write a 3. Raised to the 8 minus 1. So when you plug that in, you actually get 1/9. So now let's convert. So we're going to have y equals 243 times 1/3 raised to the n, and then I'm going to go ahead and separate and do 1/3 raised to a negative 1. So when I change 1/3 raised to a negative 1, when I rewrite, this is actually going to give me 243 parentheses 1/3 raised to the n, and then this is going to give me just a positive 3. So now you want to do 243 times 3, which in this case is going to give you 729. So we're going to have 729 parentheses 1/3 raised to the n. So that would be your exponential form. So looking at the next one over here, I'm not going to do this one entirely. Let's just look at how to find the common difference or common ratio. So I'm going from 24 to 36 to 54 to 81. So I can't just add 12. That's not going to be a clear, consistent change. So that tells me it's going to be geometric. So I'm going to do R equals, I'm going to simplify the ratio of the second term over the first term. And then divide by the greatest common factor, which in this case would be 12, which gives me a common ratio of 3/2. So I will let you guys fill in the rest on that one. I will say the value of the 10th term is a gross number, but I'll at least write it out so you can check it. So it should give you 59,049 divided by 64, which, gross. But that would be your 10th term if you want to check it. Now down below, what's going to happen is we're going to give you either the recursive or the explicit form, and you have to fill in the other one. So we're not going to outright tell you if it's geometric or explicit. You have to look at what we give you and determine that yourself. So given this recursive form, notice how we're multiplying a 3 value. So what this tells me is that this is going to be geometric with an R value of 3. So when I write out my explicit form, this would be a sub n equals the value of the first term, which is 10, times the common ratio raised to the n minus 1. So now looking over here, so I'm given explicit form. So in this case, this is my geometric explicit form. So the recursive form is going to be a sub n equals a sub n minus 1, and you're going to multiply by the common ratio. Now, the 5 right here, that's your first term. The common ratio would be the 7. So you've also got to know which value you're going to multiply by. And then over here, whoops, I just dropped everything. So if I look over here, now I'm subtracting 4. So because I'm subtracting, that tells me this is going to be arithmetic. So I'm looking at a sub n equals the value of my first term, which is 15, parentheses n minus 1, and then I got to put my common difference in parentheses because it's negative. So that would be your explicit form. All right, now looking at 13, so a chemist is studying the growth of a bacteria strain, so the number of bacteria in the petri dish is 550, and it doubles every hour. So this 550 here, so first off, this is the initial amount. So when I say initial amount, this is going to correspond to a time of 0 hours. So now we're going to look to see, does this scenario represent an arithmetic or geometric? So if the number of bacteria double every hour, then what that tells me is it's going to multiply. It's going to be times 2 every single time. So because we're multiplying, that's going to be geometric. And you could just say because it doubles every hour. So now we want to write the sequence in recursive form. So with recursive form, the only thing that we're going to need is the common ratio. And we know that because it doubles, that my r value is going to be equal to 2. So my recursive form is going to be a sub n equals a sub n minus 1 times 2. And then I want the explicit form. So with explicit form, remember, we need to write the value of the first term times r raised to the n minus 1. We have the value of the initial, which is at t equals 0. So if I want to find, we'll just say f of t. So t would be the number of hours and f of t would be the number of bacteria. So I know the initial is going to be 550, but if I want the value of the first term, I can just double it, which means we get 1,100. So this is the value that I'm going to want to write for my explicit form. So this would be 1,100 times 2 raised to the n minus 1. Now, if I wanted just exponential form, then we would want y equals a times b raised to the x, or t, whatever, variable we're using. So in this case, it would be your initial, which would be 550 times 2 raised to the x, or raised to the t, or raised to whatever variable we're using. So once again, just to reiterate, exponential is going to use form 0, or term 0, whereas the explicit form, we're going to use the first term. So you've got to be very careful and know when we're using a 0 term versus when we're using the first term. And then you could use your calculator, you can fill out the table. So we know based on hour 0, this is the initial, it would be 550. And then at hour 2, 2,200. At hour 5, it would be 17,600. At hour 7, it would be 70,400. And then at hour 10, there would be 563,200 bacteria. Gross. So 14. Here is the fun one. So you're going to let a sub n be an arithmetic sequence and g of n be a geometric sequence where a sub 1 equals g sub 1 equals 8. And you want to find a sub n and g sub n given that a sub 5 equals g sub 2 and a sub 13 equals g sub 3. So this is a lot of, what did I just read? So starting off, when I say you want to find a sub n and g sub n, a sub n is going to represent your arithmetic sequence, g of n is going to, or g sub n is going to represent your geometric sequence. So a sub n is your arithmetic sequence, whereas G sub n is your geometric sequence. So we also know, based on the information, that the value of the first term of both of these sequences is going to be 8. So based on this, now my next setup is going to be based on the given terms that they say are equal. So I know that the value of the fifth term of my arithmetic sequence is equal to the second term of my geometric sequence. So what I'm going to do is I'm going to do my setup. So I know the value of my fifth term is going to be equal to the value of the first term. So I'm going to set up explicit form. So 8 plus n minus 1 times whatever my common difference is. But we're finding the fifth term, so I'm going to replace the n with the value of 5. So when I simplify, I know a sub 5 is going to be equal to 4d plus 8 when you simplify and rewrite your explicit form. And then same idea over here for g sub 2. So g sub 2 is going to be equal to the first term, which is 8, times my common ratio raised to the n minus 1, which would be 2 minus 1, which in this case is just 1. So it's just g sub 2 is equal to 8r. So I know these two equations are going to yield the same exact value. So what I'm going to do now is I'm going to set both of these values equal to each other. So 8d plus 8 is going to be equal to 8r. So when I get here, every single term is divisible by 4. So I'm going to divide everything by 4 just to make the math a little bit easier. So divide by 4, divide by 4. So we're going to get d plus 2 is equal to 2r. So I have an equation with two variables. I can't really do anything with that yet. However, I do know I have another set. So I'm going to do the same idea over here. So I have a sub 13, I know is going to be equal to g sub 3. So when I set this up, so I'm going to have a sub 13 is going to be equal to the value of the first term of my sequence plus 13 minus 1 times my common difference, which we don't know. So when I rewrite 13 minus 1, which is 12, so we're going to have 12d plus 8. Now I want to do the same thing for my geometric sequence. So g sub 3 is going to equal to the first term, which is 8, times whatever my common ratio is, raised to the n minus 1. So this is going to be 8r squared. So same idea, I'm going to set these values equal. So I'm going to have 12d plus 8 equals 8r squared. Once again, all these values are going to be divisible by 4. So any chance I can to simplify and rewrite, I'm going to take it because it makes the numbers a little bit easier to manipulate. So that's going to give me 3d plus 2 equals 2r squared. So my next step is now I have these two equations here. I'm going to set up both of these equations to do a system of equations. So I have d plus 2 equals 2r, and then I've got 3d plus 2 equals 2r squared. So what I'm going to do is I'm going to take this top equation here, I'm going to set it equal, or rather solve it for d. So I'm going to have 2r minus 2, and then I'm going to sub in 2r minus 2 into this d value in the other equation. So I'm going to solve this system by substitution. So I'm going to have 3 parentheses, 2r minus 2 plus 2 equals 2r squared. So when I distribute, so we're going to get 6r minus 6 plus 2 equals 2r squared. So this is going to give me 6r minus 4 equals 2r squared. Now, once again, I want to divide everything by 2. I want to make the numbers as simple as possible. So that's going to give me 3r minus 2 equals r squared. And then I'm going to move the entire left side over to the right side. So I'm going to have r squared minus 3r plus 2 equals 0. And then when you get here, I want to factor. So when I factor, we want the two numbers that multiply to positive 2, but they add to a negative 3. So in this case, we're going to have minus 1 and minus 2, which this tells me my r value, my common ratio, could either equal 1 or it could equal 2. However, if I were to have an r value of 1, if I take a number and multiply it by 1, it doesn't change. So if I do 6 times 1, times 1, times 1, times 1, times 1, times 1, it's not going to change. So I'm going to disregard the 1. So this tells me my r value, my common ratio, it has to equal 2. So just like the system of equations, once I have one variable, I'm going to plug it back in and solve for the other. So I'm going to take my equation here, d equals 2r minus 2, and then plug in the r value of 2 that we just got. So d equals 2 times 2 minus 2, which tells me that I'm going to have a common difference of 2. So now that I have both a common difference and a common ratio, and I know my first term is equal to 1, now I can write my system, or I can write my sequence equations, which are going to be in explicit form. So from my explicit form of my arithmetic sequence, I want a sub 1 times n minus 1 times my common difference, which this is going to be 8 plus n minus 1 times 2. So if I want explicit form, this would be my arithmetic sequence. Now, I could also ask you to rewrite it in slope-intercept form. So this would be 8 plus 2n minus 2, which means it could be written as 2n plus 6. So I could ask you for explicit form, or I could ask you for slope-intercept form. So now we're going to do the same thing for the geometric sequence. Nope. So that will be g sub n equals the first term, which we said was 8, times 2 raised to the n minus 1. Well, here, let's write out the actual form. So a sub 1 times r raised to the n minus 1. And then when I plug everything in, so 8 times 2 raised to the n minus 1. So that would be if I want geometric explicit form. Now if I rewrite, so 8 times 2 raised to the n times 2 raised to the negative 1. So 2 raised to the negative 1 is going to turn into a half. Half of 8 is going to turn to 4. So 4 times 2 raised to the n. So depending on if we want explicit form or whether we want exponential form, that could also change. So, but this is a really good problem. So make good choices.